Okay, let's do the next question. That is the third question. That is, taking the set of natural numbers as universal set, write the complements. Okay, now taking the set of natural numbers as universal set, so we have to take the natural numbers as universal set. Okay, now here the universal set is natural numbers. Okay, we are taking natural numbers as universal set, so we can write u equal to natural numbers. Okay, 1 2 3 4 5 6 7 8 so on. Okay, these are the natural number till infinity. Okay, so this is our universal set. Okay, so now see, we can write this as this is now in roster form. You can write this in set builder form. That is u equal to all natural numbers. Okay, x such that x belongs to natural numbers. N means natural numbers. This is set builder form. This is roster form. Okay, now the first question is x such that x is an even natural number. Okay, so here all the elements of this, let this be a, set a. Okay, we'll assume this to be set a. So a is even natural numbers. So what will be that? 2 4 6 8 so on. Okay, even numbers, even natural numbers. These are natural numbers, even natural numbers. So what will be a complement? A complement is, what is a complement? A complement is equal to u minus a. From u we will remove all the even numbers. These are even numbers, isn't it? Remove all the even numbers, then we'll have the odd numbers remaining. So u a dash will be odd numbers. Okay, so we can write this in as in set builder form, x such that x is an odd natural number. Okay, so a is even natural number, a complement is an odd numbers, odd natural numbers. Okay, so just we get the opposite. If it's even, we get odd. If it's odd, we get even. Okay, so a and a complement are always opposite. Okay, so we'll see the next number. Next question is, let it be b, set b. Okay, x such that x is an odd natural number. See, odd natural number. Okay, here x is an odd natural number. So if we remove odd natural number from the universal set, we have all the even numbers left. So we can say that b complement will be even numbers. So x such that x is an even natural number. Okay, just opposite. B complement. B is odd numbers, b complement is even numbers. Okay, now let's go to the third one. Okay, let the next one be c equal to x such that x is a positive multiple of 3. Okay, so the multiples of 3. Okay, what are the multiples of 3? X are the multiples of 3. You have 3, 1 is 3 6, 3 is 9, 3 4 is 12, 3 is 15. Okay, and so on. Okay, these are the multiples of 3. Okay, this is this set. Then what will be c complement? C complement will be, remove this all from the u minus this. Okay, so the remaining numbers will be, those numbers will not be the multiples of 3. Okay, when we remove all the multiples of 3 from the universal set, we'll have the numbers which are not the multiples of 3. So we can write this as the opposite. Okay, x such that x is not a multiple of 3 of 3. Okay, x is not a multiple of 3 and x belongs to natural numbers. Okay, we have to mention this, or else not a multiple of 3. There are a lot of numbers in between. You have here 2.5. Okay, that is 5 by 2. 5 by 2 is not a multiple of 3. That also will include in this statement. Okay, this statement, because x is not a multiple of 3. 5 by 2 is also a multiple, not a multiple of 3. Okay, there are a lot of in between numbers, decimal numbers, fraction numbers. So to avoid that, we have to avoid that. So we have to mention x belongs to natural numbers. only these numbers 1 3 4 5 1 2 3 4 5 6. Okay, x is not a multiple of 3 and x belongs to natural numbers. Okay, that's it. Let's go to the next one. Okay, the next one is, let it be D. Okay, x such as x is a prime number. Okay, so what are prime numbers here? Prime numbers are, we know, the numbers which is divisible by 1 and itself, okay, which has two factors. So we can say 2 4, so not 2 3 5 7 11 13 and so on. These are prime numbers. Okay, these numbers are divisible by 1 and by itself only. So these are having two factors. Okay, having two factors. Okay, having two factors, that is 1 and itself. Okay, 1 into 1, 2 into 2 into 2, 2 into 1, and 1 into 3, 2 3 into 1. Okay, only 1 and 3, these are its 1 and itself are the factors. Okay, we have only two factors for prime numbers. So if you remove all the prime numbers from this universal set, what we have the numbers which are not prime. Okay, so what are those numbers which are not prime? They are called composite numbers. Okay, composite numbers. Composite numbers are those numbers having more than two factors. Okay, more than two factors. For what are the remaining numbers? 4 you have 6, you have 8 9 10 12. These are all composite numbers. They are having more than two factors. 1 is a factor, 2 is a factor, 4 is a factor for this. Okay, in the same way for this, 1 is a factor, 2 is a factor, 3 is a factor, 6 is a factor. Okay, so more than two factors is all are having. So these are called composite numbers. So D is a prime number, set of prime number, then D complement will be not prime numbers, that are composite numbers. Okay, so we can write D complement equal to x such that x is a composite number, and x belongs to natural number. Okay, this also we have to mention that it belongs to natural numbers, or else other numbers also will get included. Okay, so now this is okay, this is it. Now let's go to the next one. See here, 1 is not included. Okay, 1 is not included in prime number and not included in composite number, because 1 is having only one factor. 1 into 1 is equal to 1. Okay, only one factor. Here you have prime numbers having two factors, and composite numbers have more than two factors, but 1 is having only one factor, so 1 is not included in prime number or in composite number. Okay, this is not composite number, not prime number. Okay, let's go to the next one. Okay, the next one is E. Let it be E. Okay, x such that x is a natural number divisible by 3 and 5. Okay, so this set is a number, this set is the numbers which are divisible by both 3 and 5 also. Okay, both. Okay, both numbers should divide that number. For example, see 15, 3 is 5 is 15, 5 3 is 15, 5 and 3 both divides 15. Okay, and also 30. You may have 45. See, you can have 45. These all numbers, these numbers are divided by both 3 and 5 also. Okay, so and so on, lot of numbers. So this is the set, E set. Okay, so if you remove this set, remove all these elements, elements from the universal set, the numbers which are not divisible by 3 and 5 are left. Okay, so that is E dash. So we can write x such that x is a natural number which is not divisible by 3 and 5. Okay, here is a natural number divisible by 3 and 5. Here is E complement is it's a natural number not divisible, which is not divisible by 3 and 5. Okay, just opposite. Okay, or you can write also x is such that x is a number, x is not divisible by 3 and 5, and x belongs to natural number. Okay, you can write this also. X is such that x is not divisible by 3 and 5, and x belongs to natural number. Same thing we have here, natural number. X is a natural number which is not divisible by 3 and 5, or x is not divisible by 3 and 5 and x belongs to natural numbers. Okay, you can write any way. Okay.